Hello, Data. Welcome to Arithmetic Sequences, otherwise known as series. So when you sum up an arithmetic sequence, we call that a series. First, I have a joke for you. I had a dream last night that I was swimming in a sea of orange soda, right? So I was in this sea of orange soda. It turned out to be a Fanta sea. Get it? Fanta sea? All right, moving on. So sum of arithmetic sequences, which we call series, works like this. So famous mathematician from a long time ago, his name was Gauss. Friedrich. Friedrich Gauss lived like late 1700s, and his teacher was a little upset with him because he's goofed around in class, just like some of you do in my classes, and said, "Why don't you go add up the numbers from 1 to 100?" So the teacher's like, oh, yeah, I go 1 plus 2 plus 3 plus 4. Start adding those all the way up to 100. And Gauss said, okay. So he went and sat down, and he was brilliant mathematician. And comes back a couple minutes. He's like, got your answer. And remember, this is before calculators, before anything like that. And the teacher's like, what? No way. He's like, yeah, 5,050, which is the correct answer. And the teacher's like, how did you do that? So Gauss showed his teacher, and what Gauss did is he said, well, if I take 1 plus 100, that equals 101. If I take 2 plus 99, that equals 101. And 3 plus 98, and that equals 101. And he realized that if he did that 50 times, he would have all the numbers added up, because he'd go 1 through 50, and his last number down here would be 50 plus 51. That would equal 101. So if he does it 50 times, he has his answer. So 101 times 50, he did that little mathematician or multiplication. So 0, and then 5 times 1 is 5. 5 times 0, 5,050. So he figured it out by using multiplication. So there's this formula for adding up the sums of these sequences. And here's how the formula works. The formula is the number of terms over 2 times first term plus last term. And I know that may not make a lot of sense right now, but let me show you how to use this formula. So this would be the sum of all those numbers. That's what he was doing here. Let me show you how he did it. So I have this series of numbers now, or a sequence of numbers that I'm going to add. We call it a series now. So how many terms were there? Well, there was 100 terms divided by 2. What was the first term? 1. What was the last term? 100. So I have 50 times 101, which is 5,050. So he just used this little formula, and it works for every series, not even ones that go up by 1. So let me show you an example of something that you may see in your homework. All right, if I could turn the page here, we would be set, but I can't. Fingers don't work. All right, so what if you saw something like this? And it said 8, 12, 16, 20, 24, 28. All right, and it said that it's a series. So immediately when you see series, you do this: plus, 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 plus. We have to add up all those. But instead of taking the calculator and just going 8 plus 12 plus 16, I'm going to use the formula, because eventually there may be 40 numbers there, and that doesn't sound like much fun on the calculator. So here I go on the calculator. So the sum is, here I go with the formula. The number of terms over 2 times by first term plus last term. Okay, so that is, how many terms are there? Let's count: 1, 2, 3, 4, 5, 6. First term's 8, last term's 28. So if I add up all those numbers, I'm going to get 3 times 36, which is 108. That should be my answer. Now, just to prove it to you, I'm going to take the calculator, turn it on, and I'm just going to type it in: 8 plus 12 plus 16 plus 20 plus 24 plus 28. And yes, that was faster than using the formula, but eventually there's going to be a lot of numbers here. Okay, let's do another one. All right. Let's say your series looks like this: -3 plus 1 plus 5 plus 9 plus 13. And I'm going to add, so this is 1, 2, 3, 4, 5. I'm going to add up, I want to add up 20 of those numbers, 20 terms. So I'm going to put a dot, dot, dot to show that I'm just going to keep where I go, but I don't want to write that many. That's just ridiculous. So first, second, third, fourth, fifth, all the way up to 20 terms. I'm going to use my formula. All right, so I can see it above. So how many terms are there? 20 divided by 2. First term, -3. Plus last term. Now we got some work to do here to find the last term. Let me show you how to find the last term. Y equals mx plus b. Because I don't want to count by fours all the way up to 20. That's way too hard. So here's how I do it. Y equals, from yesterday, the slope is how much we go up by. Going up by 4 every time. 4x plus b is the 0 term, which means go back 1, right? So this is the first term. 0 term goes back 1, so that'd be -7 if I go back 1. So 4x minus 7. Okay. My goal is to find this last term. The last term is the 20th term. So I'm going to take 20, watch what I do with it. I'm going to plug it in. So my last term is 80 minus 7 is 73. Okay. So all I have to do now is go 10 times -3 plus 73 is 70. So 700. So if I add up all those 20 terms, I get a total of 700. Works very nice. This formula works very nice. Okay, let's do another one. This one will look a little bit different. That is the Greek letter sigma. Sigma, it's a capital sigma. I'm going to write that over here, sigma. Sigma just means to add, which is the same thing we've been doing. So if you see that, don't fret. It's the same exact thing. 2x minus 6. Let's make this be x. Don't be scared. It's the same thing. We're going to add up 12 terms starting with the first term. Here's our equation. Use the same formula. How many terms are there? 12 divided by 2. It's just what I used up here. 12 over 2 times the first term. All right, now here's how I get the first term. I take 1 and I put it in here. My first term is going to be 1 plugged in. 2 times 1 minus 6. 2 times 1 is 2 minus 6 minus 4. So minus 4 is my first term. Plus my last term. My last term is I'm going to take 12 and put it in there. My last term will be when I put 12 in there. So 2 times 12 minus 6. 24 minus 6 is 18. 24 minus 6 is 18. Again, if I go fast, pause, back up, have me say it again, should make more sense. 12 over 2 is 6. -4 plus 18 is 14. So 6 times 14, I believe, is 84. So if I add up the 12 terms of that sequence, I get 84. Using one formula today, that's it. Let's do 2 more problems, and we'll call it a day. Here are your last 2 problems. Let's do sum of, let's go I here, okay? I want to show you an I here because on the worksheet there's an I, and I don't want you to be confused. 5i plus 10. It's the same thing, it's just using a different letter. So if you prefer the x, change it. Like we have y equals mx plus b, just change it. So Greek letter sigma means to add everything up. So I'm going to do my formula. How many terms are there? 1 to 8, there's 8 terms over 2. The first term plus the last term, right? That's what we're going to do. First term is when I put a 1 in here. If I put a 1 in there, I got 15. The last term is when I put an 8 in here. 5 times 8 is 40, plus 10 is 50. Okay, so I put a 1 in there for my first term. 5 times 1 is 5, plus 10, 15, plus 50. 4 times 65, 260. Did I get that right? Yeah, that's right. Looked wrong for a minute. Last problem. You'll see this type on the worksheet too. 15 plus 21 plus 27, dot, dot, dot. And then it'll just put n equals 42, something like that. And so what that means is it means to add up the first 42 terms of that series, the first 42 terms. So here we go. And then sometimes I use the word sequence and series interchangeably, but just know when I put pluses between them, I call it, it's supposed to be a series. It's a sequence until I put the pluses in there, and then it becomes a series. So I use my formula. How many terms are there? 42 divided by 2 times the first term, 15. I see it right there, 15, plus my last term. That's going to take some work. Let's figure it out. My last term, y equals mx plus b. The slope is my change. I'm changing. I'm going up 6 every time. 6x plus my y-intercept is when I go back 1. So I'm going to go back 1. What's 6 from 15? That'd be 9. 6x plus 9. That's how I get my equation. Now I need to find my last term, my 42nd term. So this 42, the 42nd term goes right here for x. Y equals 6 times 42 plus 9. I will use my calculator. Use decimals or your calculator. 6 times 42 plus 9 is 261. That means the last term is 261. 261 right there. So 42 divided by 2 happens to be 21. 21 times 15 plus 261 is 276. 21 times 276, 5,796. So if you were to think about it like this, if I'm going to take and add all these up and I keep going, and the 42nd term I stop adding them, this is the sum I would get. That is how you add up arithmetic sequences. Some of you may have to replay this video, back it up, take a few notes. The worksheet will be waiting for you. Have a great day. Happy Wednesday.